like a whole cell. It's not like a.
We're pitching like a whole.
Yeah. Dual thing. Yeah, I don't know. I mean, I don't know. This guy goes. You can't. We're like afraid to do it. We do like a whole. Like it'll be mad, right?
Yeah, that's what
So
we're
we're just trying. So you don't think it's really upside at all, but also
What's,
not a big drop.
What's shitty about the company? What do you want?
It's like we're trying to say how
They're very
their PE is like extraordinarily high.
What is it?
It's like 33. Here's the current industrial number.
in a DCF, they're trading as a.
All right, so here's the goal: is that what we have. I put a link into Slack. Got this. Hopefully, it'll capture the audio from my laptop, so that we're going to go back and look at it again, and capture what's on the screen. That way, we can watch what we're doing together on the screen and listen to the video. All right, I think we're going to start charging ahead, boys. So I have 2 Excel files on here. I have. Is that Nick? So we're trying to capture audio for a class, so that's why I asked you to keep it down. Thanks. So we have 2 Excel files. I have one which is available from. Pull this one out. One which is available here, and this is your group.
Yep.
Okay, and I have one which is available from this group. So I know I've looked at the 1 o'clock or the no, here's both 1 o'clock. I know I've looked at this data set before.
So the one thing that we didn't know how to do is that 0 thing you're talking about. So I know you want to do that.
Yeah. Absolutely easy to do because when I demoed this before in class, I didn't really talk you through any part of it. So this team has a number of blanks where things weren't present, but in order for this data to be good for SPSS, we need to be able to replace the blanks with zeros. There's a lot of different ways that you can use the mouse to execute these things. I want to use my keyboard. So I'm going to highlight everything in column C through whatever your last variable is. It looks like L. Everything all the way down for the 200 and some odd cases here. Holding Shift allows me to select this cell, and then hitting the arrows will highlight everything else. And then I can use Control to get all the way to the bottom here. It's easier if I go all the way, actually this way. 204. So I've just highlighted now all the cells where I want to replace things that were blank with zeros. Control F would find, Control H will find and replace. I think. Yeah, okay. So what do I want to find? I want to find nothing. We'll look for blank, so I just hit Tab to go to the next field, and then I replace it with 0. So everything that was blank now becomes 0 in the cells that I've highlighted. And I'm going to replace all, and I think there's 1,625. Yeah. So now all those places where there was a blank, there's a 0. Although that still needs to say menu board. It does. Also, batteries aren't doing very well. Both of these fields also need IDs on them, or rather they just need field names or headers. So we can just call this one title and this one ID for now. So that this data is just about ready for us to import into SPSS. We have field headers, and each record is a row. So each ID of the 204 different ones you've coded has an ID number, which is unique, a title, then whether or not these things are present or absent. Let's see what the other group has. Rio copy, these you guys?
Yep.
Yeah, and it looks pretty similar here. Are these the same?
Scrolling
If you scroll over the other
to
side.
the left.
Yeah, yeah.
So the variables are the same pretty much, and but our other things.
Okay. One thing we could do is we could keep both of these data files separate and analyze them separately. I'd like to combine them. There's a number of different ways that you can combine files. Like you can use SPSS to merge. For me, I'm just going to take a look at where the variables line up and where they don't, because right now I can see that, see, not as much because my eyes don't work anymore. I can see that I have some similar variables here, which is ID, food, and so on, atmosphere, city of Providence, but there are some variables in this one which don't line up with the one below it. So right now, I just want to line those things up so that I have the same variables in both files. I don't need either of these rows. I'm going to get rid of them. I'm going to insert a couple columns here, just so things line up vertically as well. So in column B, this would be name of cafe and number of followers. Honestly, I should probably just copy that and then paste it here. Control C, Control V. E should be food. D says description on type of post. Tell me, team, what that means.
Just
Quick synopsis of what's in the picture.
what it looks like.
Is that similar to what you called the title? Yeah, I mean, like there isn't really a title on there.
Yeah, it's just like what a quick gist.
Yeah. So whether we call it description or I'll just change it to title for case of uniformity. And to make sure that I have the same variables in both documents, I'm going to copy it from this file, come to this one, and say insert copy cells. And now I have two rows here, which, by the way, clicking this thing in the top left corner highlights everything on the sheet. But really what I'm trying to do is to get this so these rows aren't such a mess. And we can just see whether or not they line up. Like this. So some part of this doesn't line up. It looks like the other file has something that has colorful drink in column J, whereas we don't have one in the benefit of juice bar, benefit juice Instagram code. I'm going to call you team 1. I'm going to call you team A so that you don't have an order bias there. But team 1 is here. So it looks like team 1 didn't code this thing called colorful drink. So we may have to insert a column in this data. But it looks like otherwise everything is just sort of shifted one.
There's also in ours there's views on video and likes on video
Okay,
and comments on video. Besides that, that's it.
cool. We'll see how more of these things line up. It was somewhere around here, I believe, where we needed to insert. Column J says colorful drink, and we don't have that information here. So I'm just going to insert a column. And do the same thing I did before, which was copy this row, insert it here, and just, this is just cleaning. This is to make sure, oh, ooh, Jeff. It's just to make sure everything lines up. Because eventually I'm going to copy likes on photo, comments, videos, comment on video. So you have a bunch of other things. Do you have?
So those three just have to do video. That was the one thing that instead of photo and video, but they already have photo. They don't have video.
They don't have video. Does it matter if it's comments or views on video? How does that?
We could keep them the same. I guess we just
You saw a lot, or not a lot, but quite a few that were like boomerang videos that they did with like coffee and stuff like that.
Boomerang videos?
It's like a 3 second repeating, like a short, like repeating
Saying that you
video clips.
Oh, okay.
of,
So
like,
we got rid of-
something. Yeah.
7 seconds on Vine was too long, so now we need
Exactly.
3
That with
seconds.
no sound.
And no sound.
Yeah. It's just like,
I mean, you could-
do they have sound? They can't have sound.
I don't think they do.
I don't think boomerangs have any sound on them.
It's basically a gift.
That's what I thought. Thank you.
All right, so we'll see how much of this stuff lines up. Comments on photo and tags. Do you have tags, group one?
No.
Nothing for hashtags? When you say tags, you mean the number of hashtags?
So you mean like people
Oh, like
commenting
if they
each
did
other?
tag
So
in
if you
on
tag
posts.
like a friend in a
Yeah.
post, that's one tag for us.
Okay.
How many people tagged in the comments? What are hashtags too, but we don't do that.
Yeah, hashtags could be an interesting variable to capture. So I'm going to take what's here already. Oh, the one other thing we need to add, and I'll put it into a new one. Is we'll start by taking everything from team A here. Copy all that stuff. Put it in here. And then come to team 1. What do we go over to? We go over to comments. We got likes. $149, all right? Since I'm pasting it into this new one, just doing a bunch of copy and pasting right now, but I don't mind here having these labels in here for now, just to make sure everything that's here lines up with what's above it. Sort of what I was checking before. Hide these real quick just to see what lines up. So this looks like it's what we can merge from the 2 data sets. The other data set might have some other things in it. And that was all this stuff. So I'm going to take this stuff as well and copy it in. Comments was the first one, and I'll put this here. Yep. Because the ones who did competitors, right? You guys did competitors. You had these extra variables, right?
Yes. Yep.
Okay. And once I get rid of this row and unhide, then we'll have a combined data set with one key piece missing. Is we don't have number of followers for anything that has to do with benefit, but we do know the name of the cafe, which is Benefit Juice Bar.
Let's see what it is now. So we get to a number of benefit.
I'm not as concerned about that since it's competitors.
Yeah.
How many does benefit? Did we say it was up to 1,000
It was
or something?
2019 the last time I looked, but it kind of goes up and down.
Yeah, it fluctuates.
It's right now at
2020.
2020.
All right. I know that's not how many they had when they started. Well, it's what they have now. So it's kind of better than nothing. And also these IDs, they can't be unique IDs anymore because we've got, because we repeated. So I'll just use a function that says add 1 to the row above it, and then copy that function all the way down. So looks like we have 353 records for a number of different variables. Did we replace the 1s and 0s? No, we didn't do those here.
Yeah.
Do that real quick. Bunch of 1s and 0s. Huge data set. What's this column? Oh, I need to replace some 0s and 1s here. No, this total is the total number of what? Who put total in there?
I did.
Total number of things you coded?
Total.
Isn't it the
The
total
ones. Yeah, it's like the total
items that were in it. So if they had like stock photo, it was a coffee
Yeah,
drink,
it's just
and it showed the
added up.
atmosphere, that'd be 3.
We had that
We
in
had
our
it
like
in, but we
list of
didn't
things we
really
didn't code for.
do it, so. Like, I think it started with,
But it was the total number of things that you found across all those different variables? Cool.
so we started it to 7, and then we didn't do it anymore, because we didn't know. We found it, so, we didn't.
Well, it's just the total number of things you have coded there. That's good. So I just put this function in here real quick. It just takes the sum of the number of things you coded across there. Now this was also the variable that we needed in here. This was the colorful drink variable, right?
Yeah.
Yeah.
You guys didn't code for colorful drink, all right? So I'm going to call this 9. There's certain things that SPSS wants you to call certain numbers. You don't have a code for that. So I could either leave it blank or I could code it 9. You know what? I'll just leave it blank for now. That's what I'll do.
Wouldn't a colorful drink technically just be a smoothie though? Like is that,
Yeah, what is colorful drink?
like if it was a coffee, would you
So the
call it as
only
a colorful
times
drink?
that I didn't just hit ones for both of those is if like some of the pages I saw would have like a smoothie picture, like a juice, but it was in like an opaque container, so I couldn't tell like what it was.
Like Sydney had like a sapphire latte,
It was-
so I guess yeah, coffee. I was just saying because it like look wise, it gives it a better aesthetic, so you know.
I think
you
I'm
don't
just
have
thinking
to
like,
have it.
But
Or,
for
like,
most,
benefit
like
juice
90%
bar,
of
like,
it,
it would
it
just
was
be-
the same. Yeah, he had one or the other.
Yeah, that's true. I
Not
guess
like
yeah.
most spots, if you have one.
Well,
Not
that's
really either.
no, that's really keen insight from the years of doing ad testing, and we worked with Anheuser-Busch for a long time. There's a distinct difference between somebody seeing a bottle of Budweiser and seeing a Budweiser being poured into a glass, where you see the bubbles, where you see the color, where you see everything, as opposed to just here, this is a cup and you know it's got coffee in it.
Right.
No, if I get to see like the everything, so there is something real to that variable. All right, so that's just a little bit of cleaning, but now we have a data set that we can pull into SPSS and do a bunch of stuff with. I'm going to save this file, just save it to the desktop, it's fine. Benefit, clean data. 7. All right. I'm a big fan of putting a date whenever I save a data file. It's that way I know when everything was done. And I got SPSS open. Now we came here, so if you want to play along, I know you got your machines, but these lab machines, I'll have SPSS on them where your machines don't. Starting SPSS is as easy as going to the start menu and then typing SPSS like this, and then hitting enter, and it will run. No, Dylan's had that machine locked since Wednesday. I think we just need to restart it. Or you can take this one and I can swap places with you, or you can use the next Terra.
So we have access to the same data set that you just made compiled.
Yeah, let me make that available to you. Yep. So here. Benefit clean data. I'll just drag in here. And team 1, I'll drop it in here as well. I dropped it in both your general channels.
Got it. Thank you.
Yep.
Yeah. We have one that all choosers too, actually, just for future. Mhm.
Oh, all juicers, everybody's. Oh, so
Everybody's-
I could put everybody into there.
Yeah.
This is Benefit Juice Club. Okay. Well, I don't drag it twice since it's already in there. You guys ready to hop into some SPSS stuff? So once it's running, now I've mentioned this a few times. Let's see if I can draw a little bit on here. All right. There's like 3 things that we have. So we have data, and data files are SAV. But right now we don't have this because our file right now is just in Excel. But we can use the XLS file to create an SAV file. You just have to open it in SPSS. And what we're going to do in order to create output, SPO. SPO stands for output. SPO. SAV stands for data. Is that we're going to create a syntax file. And that's SPS. And it's effectively the set of commands that we're going to use to run everything we want to do. It's our written record of which generates the output. It's the command that you tell SPSS to do in order to create your output. Now, I'll often bring this output back into Excel because it's easier to read that way. But the reason we can do something like this is that if Mary generates output one way and Sarah generates presumably the same question answer, but differently, like, well, why do I get something different when I created this comparison than when I created it, and so on. If you encounter that, then you've got the written record as to how you got there. File. I'm going to open the data first. And right now, it's only allowing me to open SAV files. Instead, I'm going to say open this Excel file. Sometimes you'll see CSV or even text file. excuse me, or even text files. Benefit clean data is here. Now this is the only time I'm going to use open. Every other time I'm going to use paste, because when I paste, it creates syntax. But I'm opening it. SPSS is going to look at the data that we had. It's going to say, you want sheet 1. We come back to this data and say, yeah, we want sheet 1. Range, you don't need to specify because it's taking the entire sheet. Read variable names from first row of data. Now, SPSS has a number of rules for the way variables can be named. For example, it can't contain a symbol like the pound sign, can't contain spaces, so it will probably just mesh things together. And you can see, well, no, at, oh, I guess it does. Oh, yeah, no, it can't contain at, that's sorry. It can't start with a number, it can't start with a digit, but you can have symbols like at and pound. I just use letters because they're easier to type. Ignore hidden rows and columns and so on. I hit OK. Now I'm going to create a come on. Nothing okay. What don't you like? All right. That's a weird sort of bug out. I'm just restarting SPSS because it's bugging out funny. Open data. Open this Excel file. Open. Okay. All right. I don't know what that was all about. But here, now it's a data file. I know. Were you able to create a data file? This is the data file I'm going to save, and now this is the master data. Desktop, I'll call it benefit juice data. November 12th, 2017. From time to time, you'll see that this file or this file, so this is an output file, but it's unsaved and unnamed. This is a data file. It is saved and named. But if changes are made to these files and they're not saved, there'll be an asterisk at the front of it. So the output hasn't been saved, so there's an asterisk here. Now coming back to here, I want to create a syntax file that's going to say, take this data, run these commands, and produce an output. Now, every time I add a new set of commands to my syntax, I can run just the ones I specify. I can run the entire sheet. A lot of times that's what I'll do just as a best practice. I'll use a set of keystrokes, Control S, A, R. Control S is save, Control A is highlight all, Control R is run. So when I'm running my syntax, I'll say, all right, I've added some new lines of code, save these commands, and then from the top, like you're rehearsing a song or something. So the first thing I want it to do is retrieve the data, then run all these commands. Because I may have commands that create new variables. Creating those new variables may be things I'm trying to compare. I just found that it's good practice to say, I'm always just going to start here, run my set of commands, and generate my output. But I don't have a syntax file right now. So let's create a new syntax file. And here it is. There's nothing on it, so I can't save it anywhere. Make the font a little bit bigger. First thing, get that data. So open the data, then hit the juice bar data, and rather than hit open, I hit paste. So now this command of let's go get this data, and then I'm going to run some analysis on this data. That's what I do next. Notice there's now a star up here, which means the syntax file has been changed. I just keep saving things to the desktop. I suggest you find a better file system. Most of this is stuff that we may have looked at in class, but I would have gone through it much quicker than I did right now. But if we're playing along, let me know. Questions, we feel comfortable. This isn't, I don't think, too complex, but if you haven't seen it before, there could be a lot of things that I'm just doing that I don't know if they make sense or if you wonder.
So how do you get that to that point in the syntax, like in the blank syntax? How do you get to there?
Yeah. So you opened a syntax file?
Yep.
All I wanted to do is anything I want to do. These are all commands.
Yep.
And the command I want to do is open the data. So I say open data, I select the data file I want to open, but rather than actually opening the file by hitting open, I hit paste. And I can even do it again. It seems weird, but now if I were to run the syntax, it would get this data file, and then it would get this data file.
Gotcha, okay.
But I don't need it both times. Boom. And that's true for any command you want to execute with SPSS. Is if you want to point and click to make it happen, that's great. So for example, if I want to, the way I always start is generating frequencies for all the variables, just so I can get a sense of count, so I can look at the data from 30,000 feet in the vein of describe, compare, and relate. Let's just start by describing everything we have. So I go to descriptive statistics, and I want frequencies on all the variables. Control A will highlight everything, and you can use this little arrow to bring them all into the variable list. And then there's a number of options that you can ask for. You can ask for medians, you can ask for standard deviations, you can ask for all sorts of stuff. You can ask it to generate charts such as histograms or pie charts, but you can only do one at a time. You can set up different formatting things. So for example, you have a list of variables and you want to sort them from greatest to least in terms of their average. You can do all that sorting. But I hit paste, and now it's going to try to run frequencies for all of these variables, because those are all the variables that I listed. However, that's exactly the same command as as that. So FRE is the abbreviation for the frequencies command. A lot of these commands have abbreviations. The order by default is analysis. So rather than actually including that command here, I don't have to do anything. Get rid of this for now. Control S, Control A, Control R. I have saved this syntax. I have highlighted it all, and Control R runs the syntax. I have a new output. And now it has given me a log here. You get this warning number 67, the document is already in use. You get that just about every time. because it's saying, hey, you already have this data file open, and now you're running a command that says open a data file, even though you already have the same one open. Don't worry about it. It's just saying you've opened something that you've already opened. But because you're following the format of saying open data, run the syntax, generate the output, every single time, you're always going to get that error. But it's a quality assurance thing that you're always starting from the same point. And then everything else that we have gives us a sense of what we've actually coded. So this is a good first step, just to take a look at what you have here, because it looks like there should be 353 valid responses. Anytime you're in, and SPSS doesn't like the escape button very much. Anytime you're in an SPSS output, you can double click on one of these tables and change the way it looks. So right here, this tells us a valid count and a missing number. So it looks like there were 2 of these for which there wasn't an aesthetic quality of photo number provided or coded. My mind doesn't, when I see this, my mind doesn't go to, oh, someone was deficient in their execution of the coding. It makes me think maybe there was something wrong with the way we combined the data. I think we were pretty clean with it, but you know, that could be a thing to double check, or we just skipped a couple when we were changing blanks to something else. But we'll get a better sense when we look at the rest of the descriptives, exactly what's available in our data. There were 204. Here, let me get my pivoting trays out here. Moving some things around so it's easier to read, I believe. Way too close to the screen, too. Stop it. $204 have missing variables for this colorful drink thing. What's the explanation on that?
Benefit. That's the actual posted.
Yep. So just because something's missing doesn't mean that there's something wrong. It just means it's not there. Same with comments. It looks like 204 are valid for comments. Maybe some of these variables, and I sort of skipped over that because I wasn't exactly sure what your operationalization was for things like comments on video, likes on video, your 3-second GIFs, whatever. So some part of that you may have to go back and change the coding on, or the combining the data, or deciding how you want to move forward with that. But in general, this puts us in a place where we can see what variables we have that are combined across the 2 data sets and so on. Just so you know, this same set of analyses right here could all have been performed by just typing this. It's always my first command, just so I can see what's available. Now, on Thursday, we did talk about hypothesizing some comparisons, groups that you might want to compare. That's the thing we can do next. We can also look at ways to create new variables, to combine variables, and so on. So I'm gonna ask you something like, what are you curious about? I want to start where you're curious, something you want to explore, something you want to do, something you think you still needed to do, and we'll just start doing some stuff.
Let's look at presence of like food, colorful drinks, and juice and smoothies separately and together versus likes and comments.
Okay.
'Cause that's, I think,
The most important.
Yeah.
the most that I expect to see. Like,
10-4.
a big correlation between like any of those variables and likes is going to be a lot more.
Maybe,
So which variables again, Chris?
Food. Let me see. Yeah, so food, juice and smoothies, or colorful drinks.
Juice and smoothies, colorful drinks. Now notice what happens to this font. These are sentences, right? So they don't have to start with a capital letter, but they have to end with a period.
Juice smoothie for that variable because how SPSS imported
Where is it here? Juice smoothie? Juices, juice smoothie.
So it was a slash in our
10-4.
the other one that was big for us, if we discussed
is that quality. Yeah.
For an independent or dependent variable? Well, let's do it. We can do it either way. We can do it all sorts of
That's
ways.
also kind of an opinion thing because we
It's
just
subjective.
it's a subjective thing that we put in as coders.
We didn't, yeah, we didn't see that.
Yeah, like it's not like it's.
Yeah,
I'd like to look at it though. I think because it probably is gonna have correlation.
It's like you could have coded a picture that like you being
Right.
or
I didn't think it looked right at all, but you can do
Yeah,
like,
exactly.
yeah.
Yeah, but I think that's why we get variance on whether or not someone likes a picture,
True.
because I might think it looks good and you might not.
Fair.
A bunch of stuff we can do here. SPSS learning. So sentences that start with an asterisk are called comments. So I can, for example, where it says frequencies variables, I've commented out that command. The next time, by commenting it out, it means the next time I run the syntax, it won't execute that, but it will still execute this one on line 17 where it says free all, which means frequencies for all the variables. The variables you started listing, I said, you know what, I want to capture this thought right now, so I'm going to start with an asterisk and just start typing. That way I can keep track of anything. Or make smart comments at you or at your team, whatever. It's a comment, which is really useful because you can say things like this command below runs frequencies on all variables, just like the command above. End it with the period, so SPSS no longer looks at that sentence. Go on to the next one. Now I've got all sorts of different comments in here. I can keep track of what I'm doing. Independent variable, juice and smoothies. And we were looking at what for our outcome variables? Did we say likes? Likes, comments. Cool. And while we are putting comments in here, not a bad idea to document what you're doing and when. We're doing this analysis in Ryan 107 with Mary, Chris, Tara, and Sarah on 11/12/17. Now that we know that these 6 variables are the variables of importance, I'm going to spend a little bit more time looking at just these variables, but rather than just running frequencies this way, I am actually going to go to the analyze piece so I can look at some histograms and anything else that could be useful to me there. So let's get rid of all of these variables. And let me show you a little trick that works for me. I know I want to run this command on a whole bunch of variables, but why don't I just pick one, and then I can type in the rest of the variables that I want to run this analysis on, like this. So the things I may want, I don't know, give me some median, give me the standard deviation, give me the standard error, give me a histogram. Format should be fine. And then I'm going to paste. So if I wanted to just get this standard deviation, which I specified, standard error, which I specified, and mean, which I specified, histogram, which I specified, order equals analysis. I didn't specify that, but it's just the default thing that goes in there. I can now say that the other variables that I want to look at are food, juice smoothies, this aesthetic quality of photo, copy, paste, likes, comments. So this is all now one command where it runs frequencies on those colorful drink, food, juicy smoothies, aesthetic quality, likes, and comments. 6 variables. Again, I could just run this highlighted piece. It's highlighted, Control R would run it, but best practices, Control S, A, R. Actually, best practices also starts with getting rid of your output and then creating a new one. There's that thing where we run frequencies on all the variables, and then we get an error, which is not uncommon. We get an error here after we run the frequencies thing that we just wrote. We get an error here that says warning. That's all, just the warning. Let's take a look at what this warning is. Warnings happen all the time. Juices, smoothies, an undefined variable name or a scratch or system variable is specified and blah, blah, blah. Basically, it means check spelling. So the variable, is it juices smoothies or is it
Juices smoothies.
juices smoothie? But I typed juices smoothies. Copy and paste is your friend in here. So now I run the command and it's done what I asked. In fact, we can see that yes, this colorful drinks variable, again, we knew that there was going to be some missing counts. There are 35 out of 149 which had colorful drink. 109 had food. 74 had juice or a smoothie. We've got most of them coded on some aesthetic quality. We've got some zeros in here. I'm not sure if that was, they weren't coded, they got replaced with zeros or ones when they should or shouldn't have. So maybe we go back and reinvestigate the way I combine the data. We get a sense of where all their likes are, but the histograms are really useful here because you can look right at this and say, hey, for colorful drink, most of them were zeros. Or for juice smoothie, most of them were zeros. Aesthetic quality appears to be negatively skewed around a mean somewhere like 3 or 4. The number of likes is positively skewed. In general, we don't get a whole bunch of likes. There's a few that are over here that get a whole bunch of likes, but for the most part, it's a couple likes or not. Same thing with comments. So not everything is shaped normally, but these two shapes both make a lot of sense because most posts get very few likes. And that's what this big spike here indicates most posts. Where do most posts end up? Right here. Just the way most posts end up with a 4. 4 is the mode. So I'm far less concerned what the mode is, but mostly how it drives the shape of the distribution. Cool. So now I get a sense of what the data looks like. This could be useful somewhere down the line if I decide to, I don't know, categorize these on, do you have a very small number of likes, or do you have like 20 or more likes? Do you have no comments, or do you have some comments? Because it looks like that could actually be a way to divide posts. Of the comments here, 204 that have comments, about half of them have no comments, about a quarter of them have 1, and then about a quarter of them have 2 or more. So there's really, you could call it 3 types of posts. You get none, you get 1, or you get more than 1. Yeah, I got a friend of mine who, I think I may have mentioned this before, but the way he does all of his posts is that when he posts, he doesn't put any hashtags in the post itself. But every time, that way when the post shows up on Instagram, it doesn't get flooded with ugly hashtags. But he's always the first to comment on every one of his posts with all the hashtags that he wants. That way he doesn't have to ruin the when you're scrolling through, you don't see.
Your feed isn't ugly.
Yeah, exactly. So,
That's smart.
yeah. And he takes good pictures of good food, and now I'm hungry. Sugarfish.
These are really good.
These are really good pictures.
He doesn't mess around.
Ooh, more stuff.
That. I want that in my face. All right, so let's stop getting distracted. Thanks, Tony. Let's go back to running some commands, though. Things that we can do is we can start by doing some comparisons, and if we want to compare things, we can compare means. And I mentioned on Thursday that there's a number of different ways that you can compare means. The 2 that we're most concerned about from this list of 5 things here would be either the independent samples t-tests or the one-way ANOVA. The one sample t-test is more like what we would have done in stats class, which is comparing a single sample to a population, a known population mean. Does your sample differ from the known population mean? But what we're dealing with here, generally speaking, are 2 different. We know they're different. Posts that have this characteristic versus posts that don't. They do or they don't. And that's what we would call independent samples t-tests. So the independent samples t-tests, independent samples t-tests comes from analyze, compare means, independent. Analyze, compare means, independent samples t-test. And again, you can choose any variable that you want. Generally, when I write these things, I'll start with a simple comparison. I know that the dependent variable that I want to compare, for example, is the aesthetic quality. And that's what you call the test variable or the dependent variable. The grouping variable might be whether or not there's a colorful drink present. And that becomes the grouping variable. There are 2 groups for colorful drink. No colorful drink present, colorful drink present. Continue. Then you can do, like all of these things, options, excludes case by analysis, what confidence interval do you want? Again, defaults to 95%. Exclude cases, whatever, this is fine. Again, rather than hit OK, I hit paste. And now it says t-tests for groups, colorful drink, variables, and so on. I would, in many circumstances, hop to pasting this into Excel, because I might have a number of different variables that I want to use as groups. Colorful drink, food, juices, smoothie. And rather than having to type those out or follow this click step all the time, I can set up something really quick in Excel just to change the word from one word to the next. And I have all sorts of lists and things that I can just let Excel create the syntax for me. For example, again, it always gives me this data set activate line, which is never really needed. And it's not gonna, or will it let me? Yes, right on. So this is pretty cool, but if I want to have a different independent variable or a different dependent variable, I could do this. So this doesn't look like anything right now because I put the equal sign and quotes all around it, but I'm going to do something in here which is kind of neat. I started by putting equals at the beginning of the line. And you know what happens when you put equals at the beginning of a line? It turns it into a function or a formula. But rather than having this word be colorful drink, I want it to be whatever I type here. And I can type Mary, if I could type right on the stupid keyboard. And now it uses Mary. I could type Chris, now Chris goes here. With a dependent variable, I can do the same thing. I start by putting quotes around it. It doesn't change anything. That's weird. Okay. All right, yeah. But either way, I can now set up something that just means if I want to have one of my independent variables come from this list and say an independent variable is food and the dependent variable is likes.
Oh.
Thing is, too, with the dependent variable, you can have a number of dependent variables, but your groups have to stay as one. So this can oftentimes be more useful if you're trying to set up a bunch of independent variables rather than a bunch of dependent variables. This is the output from control SAR. So when we have the independent variable colorful drink, it looks like there's a total of 147, or in some cases 141. Now the base sizes for these things can differ for a couple of reasons. One, if the variable isn't coded for a record, if both variables aren't coded for each record, which could be the case here, perhaps aesthetic quality of photo and likes weren't coded for a number of those particular pictures, then you don't get to see that. But of the records for which both colorful drink and aesthetic quality of photo are coded for, looks like there's 147 of them. The average number of likes, the average aesthetic quality of photo for colorful drink present is 4.5. The average aesthetic quality for when colorful drink is 0, now colorful drink is present, the average is 3.3. When a colorful drink is present, the average is 4.5. When a colorful drink is not present, the average number of likes is 220. When a colorful drink is present, the average number of likes is 285. So it seems to be consistent. Like, why were you coding for it? Because you think people like it more if it's present. And early suspicions seem to indicate that, yes, that's true. In order for us to execute the t-test, interpret the t-test, we got to come to this section that says independent samples t-test. There's a number of different things in here that may or may not be really relevant to us. The equal variances assumed or not assumed has something to do with understanding the shapes of the distributions if a colorful drink is present or if it's not. Not really the level we're operating on right now. Mostly the things that we need to go to are right here, which is to look at the significance value, otherwise known as the p-value. And we're basically looking to see if anything in here is less than 0.05. And to be honest, I'm just going to hide both of those because it's excess. There's a lot of stuff in here that's kind of excess for us. But we can see that the aesthetic quality of the photo is significantly different. That's less than 0.05. Doesn't actually equal 0 because it'll never equal 0, but it's pretty close to 0. It's less than 0.0005. On the other hand, this makes for our first interesting interpretation. We calculated t-statistics and stats. I don't know if those of us who didn't have stats together. Looking for t-tables. I know I have. Thought I had. I got them online. No. Yeah. So things like these, I don't know if y'all ever saw these things, or the other side of that thing, like a t-table, just for a little reference. But notice how all of the values, and go to the, like, if you go to the bottom where it says confidence level and you go to like 95%, that's a two-tailed test with 0.05 significance level. All right, so the bottom says confidence level 95%. We specified that somewhere along the line. In fact, here, we can actually see it in our here we can see it in our syntax, criteria CI 0.95. Most of the numbers in that column are right around 2. This T statistic is right around 2. We've calculated a test statistic using all 142 or however many it was, 141 observations. I'm looking at the likes one. Here we were looking at likes, we had 141 observations. So I'm looking at likes down here. We had 139 degrees of freedom. So sort of like on this table where you have 100 degrees of freedom, third row from the bottom. Now that gives us a critical value that we compare this test statistic to. Back in hypothesis testing, you compare a test statistic to a critical value. Critical values come from the table. Test statistics come from the formula. This is calculated from the data that we have. Negative 1.816 is not quite significant at the 0.05 level. 0.72. No. 0.072 is what some people would call marginally significant, or starts to indicate there might be some significance here, but at the 95% confidence level, or alpha equals 0.05 for a two-tailed test, we do not have enough evidence to suggest that that the number of likes is different whether or not there's a colorful drink present or not. So that's basically what this number is telling you. If we're going to say for yes or no, I would say that there is marginal evidence to suggest that having a colorful drink in your picture will get you more likes. However, for this variable aesthetic quality of photo, this significance level is far less than 0.05, so we do have evidence to reject the null. We have a lot more evidence here to suggest that having a colorful drink present will increase the aesthetic quality of your photo. In other words, here, this difference is a significant difference at the 0.05 level. This difference is marginally significant at the 0.05 level, or just marginally significant, because the p-value or significance value is almost 0.05. And then for any other comparison you want to execute, it's effectively the same thing. What else is in our output? We have whether or not food is present. And it looks like we had a total of 345 coded with both food and likes being present. 106 had food, 239 different. The average number of likes when food was present was 174.6. When food is not present, it's 93. We take a look at this t-test. Now, we don't have to copy and paste this into Excel. Like, honestly, if you can just look at it, and that's what you're after. This is the test for equal variances. We don't need to execute that test. It's not what we're worried about. We're just talking about this right here. We see the significance is less than 0.05, which means that the difference in the number of likes of whether or not there's food present or not is a significant difference at the 0.05 level. So we can describe some things, and we can compare some things. Questions in these comparisons before we go next level. I'll say next step, but it's really next level.
Not that we need to, but like say like yeah, food is important, but like what if like the look of the food, like aesthetic is better than that? Like, can you do that? Or is that really an option? I mean, I don't say do it now, but just in general.
It's totally doable.
You know what I mean? Doesn't that affect it too?
Yeah.
Somehow, like if like a picture of the food looks better, like your guys instead of like someone else's, but it still has food. Does it have more legs or something?
Yep. So right now, the only thing that we're looking at is independent this versus that. You're saying, what if we are looking at those that have, well, what is your dependent variable? Do you want to stick with the number of likes, or do you want to do aesthetic quality, or what do you want to do?
I guess I was just trying to, like, is that correct that, like, if the food, like, looks, like, say there's food just in it and it increases likes, but then if it increases likes more because the food looks better aesthetically.
Mm-hmm.
Did you get what I was saying?
Yeah.
Yeah, I did.
I
I
do.
don't know if it's important. I just,
No, it's totally
So you
important.
would set a dependent variable to aesthetic quality instead of likes? Or-
No, I think the dependent variable is still likes. You're still trying to figure out if somebody likes something more. But in this case, you have two independent variables,
oh,
food and aesthetics.
yeah.
And
I
see,
guess
my
I-
thing
yeah.
is similar to that, but we just did like any kind of product in it. So like, if you have a product in your picture, it's not just atmosphere. It's like a drink, a smoothie, a coffee, or food, and how many likes does that get versus if you don't have anything like that.
Yeah.
If you have like text, if you have.
So these are different sort of analyses. There's another thing, and this is all exactly where we're going. So Chris and Sarah, you did all competitors. Mary and Sarah, you did all benefit juice. When we're doing these comparisons here, combining them, we're saying that we're not concerned about whether or not benefit juice was the source of this information or not. Any one of these combinations of, so name of cafe, benefit juice bar, that's true for a lot of them, but it's not true for all of them. So I might start by saying, let's see. For now, we're going to continue to look at all posts, all 340 some odd posts. Though I think we probably would get a little bit more leverage if we looked at them independently.
As benefit versus competitors.
Yeah. And we'll talk about how we do that. But for now, let's take a look at, in terms of food and aesthetics, let's see what that overlap is. Or if we want to create an independent variable, which is like what Chris was talking about, whether or not a drink or a smoothie or a coffee or any of these things is present. I'm going to create what's called a crosstab, sometimes called a contingency table, with food and aesthetic quality photo. If you wanted to create this yourself, you go to Analyze, and this is still in here. Descriptive statistics, crosstabs. But I run this line right here. Oh, you gotta put the operator by in here to see. Well, we'll see what we see. $351 posts. 84 got 5s for their aesthetic quality. 123 got 4s. 78 got 3s. 44 got 2s. 14 got a 1. And 8 of them got a 0. And again, where that 0 comes from, that I'm not concerned about where that comes from right now. I probably honestly should be much more concerned, but I'm not here trying to make this 2 hours on data cleaning. I want to talk about analysis. And then whether or not food was present. So food was present in 109 of these. It was not present in 242. So we can start to get a sense of whether or not these things differ or they're connected. Crosstabs is one way we can look at it, but just as well, we could ask the question, do these things have an impact on one another? So I'm going to take this same command here. Rather than have likes as my dependent variable, set a quality of photo. We go to the significance here. It says, yeah, it looks like there's a significant difference between those that have food and those that don't have food in terms of the number of likes that they have. That for the 109 that have food, their average likes is 4. Those that don't have food, their average likes is 3.35. In other words, it looks like that those things that have food in them have a higher aesthetic quality than the things that don't. But we also said those things that have food in them, we said they have more likes, or was it marginally more? What was our conclusion on food?
Are you saying does food increase likes?
Yeah.
Yeah.
Yeah,
I think
definitely.
yeah, we came to that, yeah.
What was the one that was marginally significant?
Yeah, I can't remember if that was the one that was. I think it was.
Colorful-
Aesthetic quality and
I think
likes
it
was
was
marginal.
colorful drink.
Yeah, colorful drink wasn't.
Gotcha.
Food
Was.
Food for likes. Yeah, food was definitely likes. So we,
And food for aesthetic quality has a significance as well.
right. So there's a couple of different ways that people would suggest you go about doing this analysis. I like to think about who my audience is going to be. Sometimes the academic audience wants to see you go through some rigorous song and dance for your general linear model, chapter 15 stuff, GLM. And if you want to do that, then we're in here. Doing general linear model stuff. General linear model is a complicated way of saying linear regression with extra bells and whistles. It's general, it's generic. Linear model, like linear regression. We've got a whole series of other regression functions in here. But for me, I would tend to think about saying, my dependent variable remains likes. But what if I only looked at food pics? Are aesthetics and likes related? What if I only looked at non-food pics? Are aesthetic quality and likes related?
And you could do that for any other variables as well, right?
Mm-hmm. So the way these things are, the way these hypotheses are stated, or rather research questions are stated, this would involve us executing a correlation. In all cases, we have to learn about being able to temporarily select some things. For example, temporarily select if food equals 1. And then the next line that I run is going to ignore everything where food doesn't equal 1. So I could correlate aesthetic quality of photo with likes. And I see that the correlation here more space, more space. For those 119 where food was present, the correlation between likes and aesthetic quality of photos is only 0.15, the significance of 0.119. So it doesn't look like when we're looking at only food pictures that the aesthetic quality of photo and the number of likes it receives is correlated. What happens if food is not present? If food is not present, there's 242 of those non-food pictures, and the correlation between aesthetic quality and likes is 0.25. That's a weak correlation. I mean, it's not weak, but R squared for that's only 12%, so it's not huge, but it is significant. The significance value there is less than 0.05. So in some cases, people may ask you to generate a regression model. We haven't looked at regression today, but may look at a regression model, which is effectively like correlation. Regression and correlation are the same thing. In fact, simple linear regression is nothing more than correlation. But this is a case where I can say to my audience, it's really important that if you post something that doesn't have food in it, that it's aesthetically high quality. So all of those skeleton pictures, all of those, there's no aesthetics to this. You're not going to get likes. And regardless, like it's kind of, sorry, Tony, but it's hard to not take a good looking picture of good food.
Yeah.
Or it doesn't matter, like it's food, I want it. But this could be a case, and you know, this was something that again we discovered years ago, but you're talking about now is like if you show me a cup, there's no food in that picture. There's a cup, but if you show me what's in the cup, that frothy cappuccino with the funny design on top, I want that, like as opposed to your mug could look cozy or that's just a bottle. Who knows what's in there? But if you start pouring that orange juice and you see the bubbles and it's slow mo, you're like, I want that. So to me, of all of the other ways that the general linear model is going to suggest that you create multiplicative terms for your regression and doing more complicated stuff, I tend to think that this is better, is a better way to understand the mathematical relation that's called moderation. There's mediation and moderation. But this is moderation, which is you control for and this is totally next level stuff, but you control for a contextual variable. In other words, the way we did temp, select only food. And then you run the relational analysis, like we just did the correlation. And we see that when we ran this, looking at the food pictures, it was not a significant correlation. When we took food out of those, there was a significant correlation. So the presence or absence of food has an effect on the relationship between the aesthetic quality and the number of likes. hard to talk about, and this is what you were trying to do with 3 different variables. How do you talk about how these 3 different variables go into play? And I think that's an easier way to capture it, to understand, to deliver that message, as opposed to, I ran a general linear model with 2 independent variables in the interaction term. The interaction term was significant. It's just not as end user friendly, for what it's worth. But this also means, again, anytime you want to do that same thing that you were talking about here, does the presence or absence of a particular variable, such as food, such as, I mean, any one of these other ones we looked at, the presence or absence of a colorful drink, the celebrity being in there, whether the city of Providence is there, whether there's a coffee drink, whether there's a comment on the video, or any of the other different variables, a juicy or smoothie being present. You can do all sorts of stuff like that. You can even do the same thing with comparisons. So if I said, again, we'll temporarily select if food is present. Let's run a t-test. And the t-test I want to run is not about food, but is about the presence or absence of juice smoothie on the number of likes. And before I even run this, so now I have what looks like it's a bunch of complicated stuff.
So, what would that run?
So this is going to set up 2 different questions, but it's basically 3 variables, which is first, whether or not food is presence or absence. First, if food is present, does juice affect number of likes? Then, if food is not present, does juice affect number of likes?
Wouldn't it just be like if there's no food, then it's a juice picture? Will it likes go up?
Well, if you have a table of juice with like a sandwich and stuff, right?
Yeah, I guess
Is that what this is saying?
absent one. Yeah, I don't know.
So let's first do this. Crosstab juice smoothie by food. Because we're going to see that there's 4 types of pictures. None of either, one of one but not the other, not the other but the one, or both. Are 353 pictures. 26 has both, 196 has neither. And then 83 have food but no juice, 48 have juice but no food. So the first thing we're going to do is say, only looking at those 109 which have food. Temporarily select if food is 1. Okay? Compare these 83 to these 26. Are these 83 more liked or less liked than these 26? And then the next set is, okay, temporarily select if food is 0. We're going to look at these 244. Presence or absence of juice or smoothie. Are these 196 liked more or less than these 48? You could do it in the other order. You could say, I want to look at these 279 where there's no juice. Does having food be present make a difference? Let's look at these 74 which have a juice. If you have juice, do you also need food or not? There, and then, so we can run all of this. There's another way you could do this. Compute food and juice. equals 0. So let's before I go on to that, let's run this stuff so we can actually draw some conclusions. Let's get rid of this because we're done here. Don't save the output. Run it all. So log, what I like about the log here is although it's small, it shows me what I did. So I copied this log. If food is 1, compare whether the presence or absence of juice affects the number of likes. Right here. (106), where food was present. 24 also had juice. 82 didn't. When juice was present, we saw more likes. Is it significantly more likes? Let's take a look at the t-test. Based on our degrees of freedom, which is pretty small, and the mean difference that we actually calculated here, what is this difference? Okay. The difference in the number of likes here, the sampling error, is only about 24. These only average about 24 more likes. These are the food pictures. You get a few more likes if there's juice present. Is that few more likes when there's juice present a significant increase in the number of likes? No, that is not a significant increase in the number of likes. The significance value is not less than 0.05. So for the food only pictures, this difference is not significant. Then we do the same thing. Let's get rid of food and see what happens if we get rid of food. Now we see something that I'm going to guess is, again, really what we're after. No food, 45 had juice, 194 didn't. The average number of likes was 73 versus 78. That's a sampling error of about 100. If you get rid of food, having juice increases. That's what this means. We get rid of food. We get rid of food. We can have juice or we don't have juice. If we have juice, the number of likes increases by more than 100. Is it a significant increase? Well, we take a look at the t-test. The 237 degrees of freedom, our significance value is less than 0.05, and we say, aha, if you don't have food present, because having juice present significantly increases the number of likes that your post gets. Maybe it has something to do with that you have to have at least either a food or a drink, but you don't necessarily have to have both.
Yeah.
Come back here, and we create a variable called, rather than food and juice, food or juice. I'm going to say from the start that I haven't coded any of them, so they all get the value of 0. But if food equals, I hate using the keyboard. If food equals 1 or juice smoothie equals 1, food or juice equals 1. I just created a new variable, call it food or juice. So now it looks like there's 157 that have either food or juice. 196 have neither food nor juice. If we want to double check that, which is a pretty good idea, food or juice by food. Crosstab food or juice by juice smoothie. Just to make sure in our crosstabs, this is our new variable, food or juice. 1 should have 1s here, and if this is 0, this should not be 1. In other words, this 0 means if you have a 1 on food, you do not have a 1 on the food or juice variable. Same thing, this one. Zero here. Yep. 0 here means that our compute variable here, food or juice, this variable was computed correctly. We didn't have any rogue things ending up having 1 that didn't put it in both. And then we can say this command that we just ran, I want to do a t-test on the number of likes, but I want my independent variable to be food or juice, and run. There were 151 that had either food or juice or both. 194 which had neither food nor juice. The average number of likes here was 176 versus 73, a sampling error of more than 100, which is definitely significant as these standard errors are pretty low. This is like a standard deviation set that takes into account our sample sizes. So I can tell here that this difference is 100, and our standard error, pooled standard error, is going to be somewhere around 9, which means 18 would be a big difference. We're going to see something here on the order of a t-stat of 9 or 10, maybe a little smaller, because I can't do math in my head. That's why I got good at this. And here we are. Significant t-value, because this value is less than 0.05, means that having a food or a drink is significantly increases the number of likes as compared to having neither food nor drink. You can do with the data set that you have, and we've been here almost 2 hours. I imagine if you're learning, your brains are buzzing, because that's what happens. But we've done so much stuff today just with t-tests or things that you learned, crosstabs are things that you learned, correlations are things that you learned in stats. They're all just really, really functional ways to answer the different types of questions. But if you can understand the logic behind, like Tara, the way your question was, let's start with only looking at food pics. Now let's compare. For the most part, your dependent variable seems to be the number of likes. So this t-test command right here, these 4 lines, you're just basically swapping out this independent variable with something else. If you want to do that 2-stage process, only look at whether or not food is present or absent, or only look at whether or not juice is present or absent. You have these 6 lines that you copy and swap out for whatever other things you want to do. The last way that we could look at this would be to do, let's see, compute. I'm just going to call it FJ because I need to set up the data in a certain way for this ANOVA, or analysis of variance. On Thursday, I mentioned that t-test and ANOVA effectively do the same thing. Now, when Tara was asking her question and she was talking about what if we have this, or what if we don't have this, or how do we have like these, you know, food or juice, food and juice, only food, only juice, that's effectively 4 groups, and we saw that in the crosstabs. If we were to say, if food equals 0 and juice's smoothie equals 0, then we'll call FJ equals 1. If food equals 1 and juice smoothie equals 0, FJ equals 2. If there's no food, but there is juice, FJ equals 3. If there's both, FJ equals 4. Free OJ, or FJ. And then we run this. And now we see we've created 4 groups. Now these are not ordinal. This is a nominal variable because it's nominal, because it's classification. 353 posts, 26 had this label 4, whatever 4 was.
4 was food and juice.
Food and juice, right. It's a shame there's not a way for us to write in here, could be value labels for FJ. 1 is neither. 2 is food, no juice. 3 is, by the way, it's not case sensitive. I'm just trying to write things that look a little nicer. Juice, no food. This is both. I run this. Doesn't look like anything happened, but when I run free FJ again, I now have labels. 26 have both, 48 juice, no food, 83 food, no juice, 196 neither. So value labels, I just need value labels for which variable? FJ, 1, and then apostrophe, 2 apostrophes, 3 apostrophes, and with a period. The last way to compare means, way ANOVA, would be to make likes the dependent variable, to make FJ the factor. Post hoc analyses, all of these different tests are effectively ways to determine which of those 4 groups are different from any of the other 3s, rather than doing things paired or comparison-wise. Which ones are better than the others? I don't know, nor do I have time to figure that out.
Should juice and smoothie be separate variables?
That's a coding question.
I would say just when you look at some of the posts,
They're
defining
really
whether,
similar.
because sometimes like can you even tell the difference in pictures sometimes? They have a bunch there, like even like juice or a smoothie, it's just a fruit drink of some kind.
Yeah.
I'm past coding at this point.
Yeah, I agree.
But all those clicks I just did sets up the command that they don't call ANOVA, they call one way ANOVA. One way, rather than crosstab, rather than correlation, frequency, t-test, one way is the command that SPSS has to run in ANOVA. Likes is the dependent by that variable fj. I want some descriptive statistics, so I want the means of all of those 4 groups on likes. Post hoc tests, I don't know, Tukey, Chaffee, LSD. At some point, someone said choose those, so I continue to do so. Alpha level's 0.05. And then we run it. And we get a log here, which says we ran that command that we just ran. It gives us means for all these groups. The mean number of likes for those 4 groups looks like that. The average number of likes for all 345 posts was 118.2. By having both, you get the most. By having neither, you get the least. It seems that juice may be slightly better than food exclusively, although those 2 things look really close to one another. All of those 3 things are on the order of somewhere between 170, 190, sort of like that twice as many as this. One of the challenges you have with this sort of analysis, though, immediately is where I go. You have 345 total. 345, if you divide that by the number of groups that you have here, you end up with an average of somewhere around 80 per group. But in this case, you have one group with less than 30, one group with less than 50, and one group that's more than half. So when you say, I have all of my everything, and I have this group, and this group, and this group, and this group, throw them all together into a single analysis, an analysis of variance. You end up losing a number of, and we're not really discussing that here either, but you end up losing a bunch of degrees of freedom because you have groups of very small size. These numbers mean far less to us, except this one right here. The F value here and the significance, which is your P value here, just like when we had those t-tests and we looked at the t-table and said we have a critical value, we calculated a test. In this case, this is our test, which is 15 or whatever. That's our test statistic. If we had a table, we would be comparing it to a number probably around 2 or 3. Here's those things between groups and within groups. Those are the 2 things that are creating a ratio for us, which will generate an F statistic. In this case, it's significant. This means there is a significant difference between at least one group and one other group. Which group and which other group? In order to do that, we have to execute our post hoc tests, of which I specified a whole bunch of them. And so a whole bunch were produced. So whether we're looking at the Tukey, the Chaffee, or the LSD, we're effectively going, let's compare neither to all 3. Let's compare food, no juice to all other 3. Juice, no food to all other 3. Both to all other 3. We have a difference between the groups and the significance level associated with that difference. Again, we're looking for things in this column which are low. I've indicated them with red here. Anytime you see red, that means the significance value is less than 0.05, which means the difference is significant. So if we use this post hoc, or this post hoc, or this post hoc, generally we see the same pattern, which is that having neither makes you significantly different from all the other 3. that having food and no juice makes you significantly different from having neither. From neither. From neither. So it's really mostly neither versus everything else. Same here. All of these are the significant ones, which is neither versus, neither versus, neither versus. We do the LSD post hoc, neither versus, oh, there's some weird shading in here, but that doesn't really matter because it's just basically whether you have neither or you have either or both. Is there an added advantage to having both? On average, it's a little higher, but it's not significantly higher in the case of having both as compared to either of these. Again, this would be a case where if both were significantly better than having one of those, we might compare it that way.
I feel like fruit and juice are at that point.
Yeah. If you wanted to keep digging down, because that's always what you can keep doing here, you might say, okay, temporary, select, sorry, temp, select if fj does not equal 1. NE means not equal. So only select those where there is either food or juice or whatever, and then run the same test. Or you could even say, I don't know, you could combine, you could create a new variable which combines these two and say both versus only one exclusively, but not both, versus neither. Does that make sense? I mean, that would be, to me, the combination would be something like, I look at this, and I see that this 24 is a small sample size, but it is a meal because you're showing me a food and a drink, and you're indicating that this is a place where I should come down and have this complete. Whereas this, if I just see juice, it's come down and have a beverage and socialize. If I see just food, it's come down here if you need a snack. But you probably don't want to be grubbing a sandwich and having a conversation because that's not what you do. You get your cup, you swirl it around, you have a couple sips, you commiserate with your friends about, oh my gosh, I got so much work to do. But you're going to sit down and have this grubby meal and do work? Probably not. So maybe you want to look at having both as compared to either one. To combine groups and get a larger base size, which means you might be able to detect certain effects where you couldn't before because you're increasing your base size. That's sometimes where the art part of this comes in, is trying to come up with logical justifications to say, what if I wanted to compare things that were exclusively juice to things that may have food in them? Because food, no juice has no juice. This has both, but what if I want to say, can I just put some juice out there? Or do I need food? Or however you want to combine them. All the instructions you need for all of that stuff is right here. You just sort of need to swap out some different names of these variables. What are the things that you report when you start thinking about reporting? Like, there's a whole bunch of nonsense in here. The only thing that people ever report, if you report an ANOVA, you would report this as italicized, capital F, open parentheses, actually, this is how I would report this. It's everything that's available over here. Which indicates to me that I conducted an F test, which is ANOVA, with 4 groups, 3 degrees of freedom, this value here. 341 is relative to the number of individual records. So this little thing right here, F of 341, tells me things about the nature of my test. 4 groups, 3 degrees of freedom there. And 341, which is within that group, how many individual degrees of freedom do I have? The within groups number is based on number of records. Between groups is based on how many different groups that I have. 14.8 is the value that I got under this F column. And the significance value is less than 0.001. Rather than just say it's less than 0.05, I know it's smaller than that, so I can report it as 0.001. Rather, just to give you some sense of like, this is a massive thing to try to report all at once. This is the only stuff people ever care about if you write it up. But to me, I'm more concerned about if we were just able to go back up to where we were. How about this? This is even here. Like, this is a nice bit of change chart type. Oh, boo, Jeff. That's not what I wanted. Change chart type, give me a pie chart. And then you can change things on this chart so that it includes the piece of information from here. That 55 or about 56% had neither. So you would say that this big chunk right here, of all of the posts that we coded, 56% had neither. 23.5 had a combination of both, had only one, had only the other. That's an interesting use of a descriptive pie chart. Also, strategically, we did a lot of things up here based on that question of if food is absent or if food is present. We may also want something. And what was that called? It was called location. What was the second variable?
There was
Name of cafe. Oh, ick. Because name of cafe has a strange character in it.
it's a little.
Yeah. Yeah, that's our 630. I know we're there, but if that equals benefit juice bar, benefit JB equals 1. Now I'm only including this line. How this works. Because when we were looking at food presence or absence, this presence or absence, and then did some t-tests and whatnot, we also said you might want to compare just looking at benefit. So you're going to do a series of commands that just look at benefit. And I think this is, yep. You're going to want a set of commands that look like this to create a variable called something like benefit JB, which now means I created this variable. Benefit JB is 353 instances, 204 are ones, 149s are zeros, and those numbers should be pretty familiar to you at this point. But now you can use that variable, benefit JB, and exercises such as, well, any one of these things.
Yeah.
Like especially where we're doing the temps. Like,
So could you also do like for other, just like for any competitors, do the same kind of thing? So you separate out the 149 that are not benefit juice and then compare them on the same table with like the variables. You can do that too. Yeah.
oh, because you're gonna. Oh, I've completely jacked this now. Ooh, that's interesting too. So if you only select non-benefit, you only select the competitors, there's the average number of likes of juice or smoothie present is 274 versus 219. Marginally significant difference that we get more likes if there's juice present, which we didn't see for the entire corpus. So now we've got, was it benefit? Was it not benefit? Was that the variable of interest? Was it food or not food? Was it aesthetics? Was it liking? But if we just sort of focus on the different ways we can chop up competitor versus benefit, perhaps food versus non-food, juice versus not juice, both, neither. The dependent variable seems like likes. If you just keep chopping this up into different ways, if it's all t-tests, you can even do that one way if you get used to interpreting that and say, you know, it is all right for you just to run it this way. You're creating variables. But these are a number of different strategies to effectively accomplish the same goal, which is a bunch of comparisons. Sometimes you got to create some variables like this, computing the benefit JB variable. But doing stuff like this, I think that's what you're after. So that's our 6:30. I will, if you got more questions, I'll answer those questions. But this is about where I feel like whatever.
You can save all of this, right?
I'm gonna save this. I'll post it to. Yeah. Of course. Hopefully this captured everything on that YouTube link. I think I sent the Hangouts link, but once I get everything here, yeah, this isn't all juicers. I'll send it to all juicers. All juicers.
Also, something that might have an effect on the competitor post is the number of followers each account has. Because I did some that had like around the same, like around 1,000, but one of the ones that did a lot of had like 12K. So
because like
you have
Katie
400
Donuts
likes, that
has-
would skew the amount of people.
Obviously, yeah.
So if
yeah,
you're getting an
you can
average of
also
400
like a
likes each
ratio
post,
Yeah,
we should look at
Yeah.
separating based on followers as well.
Yeah,
Because that could skew the number of likes if you have like more people looking at your pictures. Regardless of what's in getting more likes than
like
benefits
that
going
really
to.
change it.
That could really change it. So we should look at that as well.
But are some of the competitors, do they have like the same follower base kind of?
Almost
Um,
all- At least for what I
what's
did,
the-
almost all of them were like around the same.
Oh,
But then there's one or two that had like we did big like 12.8 thousand.
Yeah, so let's see. City Prof is like 5,000. Need
I'd say
says 13.
1,000 to 5,000.
2,000, 9,000,
There's so
6,000,
many.
5,000, 12, and then one of the ones I did at 24.
But it's also so hard for
And then
businesses.
1,500. There's one from I did it from Wakefield that had
Country?
1,500. So a lot of them were
I don't know
similar.
if we
Most
did.
of them had a little bit more.
Oh, yeah.
We did the shop.
So one of the things that you might want to do in that regard, and just in part of your write-up and your storytelling, is say, we recognize that some of the competitors we looked at had more followers than benefit. Between, because you've got the number of followers coded
Yes.
and number of likes. If you demonstrate a positive correlation, you say, look, we know that more followers means more likes. It's a potentially confounding variable, but no study's perfect. So if we had more time and more resources, we would only code competitors with the same number of followers.
Yeah.
So we would have like apples to apples on that.
Right.
There's again
They're
more.
pretty similar though, besides like a few that are like 12.8. Like they're all 1,008. I mean
They're
5,000,
all
right?
between 1,000 to 5,000, except for like 3
Right,
other
that's what I
companies.
mean. Yeah,
It's just we
that
did a
is-
lot of posts for each of our competitors. So when you have 30 posts from the one with 12,000 followers, it's a lot of data.
Right.
Word. All right. So I hope that got you started.
And then is this clean data Excel saved? I'll put this in the slide too.